So this time let's talk about the. I think it's if you call it common sense, then it may be a bit complicated, but it's not really something. It's not really a theorem. It's the product of the consecutive probability that the the memory survive to the next token. In the linear case, if the probability of this, if the probability of success of the next term, given the previous term, are all correct, follows a linear trend with increasing with a greater than zero. The probability of the term survives to the next token is linear with respect to the index, then the distribution will follow. Of course, will follow pi 1 minus p and pre. But this term here, I just want to point out that it can be simplified, or maybe not simplified, or somewhat simplified, or compared to other functions in this form. So a to the power of n gamma of n plus 1 plus b divided by a divided by gamma 1 plus b divided by a. I hope how to prove it. So first, you notice that for gamma function, one property of gamma function following the property of factorial is gamma of x plus 1 equals to x times gamma of x. So you can continue to write gamma x plus 2 is x plus 1 gamma x plus 1 is x plus 1 x gamma of x. So this gives you the form. You could sort of see this is x plus 2 divided by gamma of x it's just x plus 1 times x. This is just and of course x plus m divided by gamma of x is just x x plus m minus 1 times x plus m minus 2 times x plus m minus 3 dot to dot and all the way to x. So this is x times x plus 1 every term up to x plus m minus 1. Of course, m must be greater than 0. So this gives so this form gives a product of some linearly spaced sequence. But the problem is we didn't really say that so in this form the m has to be an integer, and of course as x starts from some values and it goes up one by one. But here we don't really have one by one. We have ai plus b. So what happens in the form? I think we can ignore the probability stuff because this is just algebraic property. So the p of I. So we can write this as a form. We're just interested in Q product of arithmetic sequence. So this I equals to 1 from 1 to n, and this is ai a times I plus b. So all the way to n, but you can. So we are just interested in this algebraic structure. I mean, a lot of books has it, or maybe, and also Wikipedia has it, and Stack Overflow, and it's seen on every lecture. But just in case it's not trivial to you that this is equal to this, let me just review this a little bit so that we can divide this term by a, and we can divide it by a, and then times a. So what we get is I is from 1 to n, and then this is a times I. Well, we should use k if you don't want to mess with. So I is just index, so I just don't want to get confused with the imaginary number I. So this is divided by a, and times a. So for each term, and the product. So this is finite product, not dependent. So a is not dependent on I. So you can move this out. So this a becomes a to the power n times the whole thing, right? The whole thing. And if you divide this by a, what you get is a to the power n, a product of k plus k plus b divided by a. I hope this is clear. And yeah, and of course we want to get this into some kind of form of this one, and you could say this follows. Well, this I should mention that this one works for any number, so it does not have to be follow the integer. So this is a to the power n, and this form is from k from 1 to n. So the starting term is k plus b divided by a, and the ending term is n plus b divided by a. So this term becomes this term. We just plug in this and this x will be k plus b divided by a, and here we have k plus well, here we have n. Well, this is right. Let's say this is, oh yeah, this is 1 plus b divided by a, and this is because k equals to 1 for the first term, right? K equals to n for the last term, so we have this, but then this is not good because x, we are summing from x to x plus m, so here is x plus m minus 1, so we have to get it in the form of so this part is in the form of gamma of n plus 1 plus b minus a divided by gamma of 1 plus b of b divided by a. So that n plus 1 plus b minus a is this x plus m term, and this minus 1 gets you n plus b minus a, and then the one term and the one part cancel out. So basically, this is a proof, and yeah, it's quite it's nice form that sum of a cumulative product of arithmetic sequence is this. Yeah, so it can be useful. It can be useful for the memorization problem, but I just briefly mentioned this because it's. I think this is quite trivial, maybe to you as well, and yeah. To make things a little bit clearer.